Okay, so up to this point in class, we have talked about conic sections, but we haven't talked about shifted conic sections. So this is a conic section that has some transformation on it, right? Like a translation. So we've shifted up or down or left or right. And what obviously we'd expect is that these shifted conics are moved away from the origin, and therefore some of the features that we discussed about them will also be shifted, right? So our vertices, for example, might be shifted, or our foci might be shifted. It really depends on which conic section we're talking about. So what we're going to do is we're going to look at our conic sections, in particular conic formulas, and we're going to see how a shift to these values will affect the formula. Okay, so we'll start off with a parabola, and with a parabola, we're going to have, remember, base formula was kind of like an x squared equals 4py type deal. This is now going to be converted into an x minus h squared equals 4py minus k. So in this case, we have the vertex at the point h. Okay. Okay. Now we can also do this in the other direction, right? So y minus h squared equals 4p x minus k. And actually these values, these h and k's, are going to be flipped, right? So it's going to be the y keeps the k value, right, with the actual y coordinate of this, and the h will be with the x. Okay. So this will be kind of the transformation from the parabola, right? And I can put this kind of version here as well, so we can see both. Yeah. Okay, so parabola again, pretty straightforward. We just shift these pieces. What about our ellipse? So our ellipse formula looks something like x squared over a squared plus y squared over b squared equals 1. Now this is going to convert to be x minus h squared over a squared plus y minus k squared over b squared equals 1. And so in this case, all that we've done is move the center from the origin 0, 0 to h. Okay. Okay. So again, kind of going through, we've got our parabolas, we've got our ellipses. We also will talk about our hyperbolas. So for our hyperbola, remember our formula was either x squared over a squared minus, so we have the subtraction here, equals 1, so very similar to the ellipse, or y squared over a squared minus x squared or b squared equals 1, depending on which direction we were kind of moving and what our transverse axis was. And so with these, we convert same as you'd expect, x minus h squared over a squared plus, sorry, minus y minus k squared over b squared equals 1. Or if we're the other way, y minus k squared over a squared minus x minus h squared over b squared equals 1. So in this situation here, again, we have our center at hk. Okay. We might as well, while we're here, talk about the circle as well. So remember our circle, our base equation of our circle at the origin is x squared plus y squared equals r squared. This goes way back to the beginning of the course, and we actually talked about the formula for a shifted circle as well. So this was x minus h squared plus y minus k squared equals r squared, right? Where this, in this case, has a center at hk. Okay, so those are our 4 conic sections, our parabola, ellipse, hyperbola, and circle. And what we notice is that we have them shifted from the origin, with that's the vertex or the center of this conic shape. And once we shift these, other features also shift, right? They shift in the same way. So if I, again, sort of shift in my circle, let's say right 2, up 3, different features about the circle would shift right 2, up 3, right? Or same thing with the ellipse, right? You move the ellipse that direction, then the aspects of the ellipse are going to move also. So our goal is going to be, looking at maybe these forms, or even given information creating these forms, but we really want to know how to pull these pieces of info. So what I'm going to do, I'm going to do a couple practice problems here We don't inherently know necessarily what the conic shape is, right? So we're supposed to be able to determine what of the four we're working with. And so it should be pretty obvious that if we have, the plus or the minus situation going on when it's equal to one, then that's supposed to be one of these two, ellipse or hyperbola. The parabola has a very specific shape, so we should kind of be looking for something squared and something not squared. And then the circle again has a pretty distinct shape. It's a kind of an addition, but it's not with one, right? So we have this kind of addition like an ellipse, but the end value is not going to be okay. And these are going to be different, right? So like this could technically, I guess, be one, right? R could be one, but the A and B values are in this case different, right? So this could be 5 squared, this could be 7 squared. And so the multiplication over here would not be something R squared because those two numbers are different. Okay. All right. So again, with this being said, let's kind of try a practice problem. So here, like I said, we're not going to be told necessarily what the conics are, what conic section we have. So I might be asked to take this equation, which is x minus 2 squared over 25 plus y plus 1 squared over 9 equals 1. And I'd want to kind of figure out what conic section we are and then give its appropriate information, right? Whether it's the center, the vertices, the foci, whatever it is. So in this case, we should first note that this is an ellipse. So we have an addition, and these two numbers are different from one another. So that is the formula for an ellipse. I also know that is an ellipse that's been shifted. So it's an ellipse with a center at 2, -1. Remember, x minus h, y minus k. So the negative is already kind of in the quote unquote formula. So the center is at 2, -1. Where would my vertices be? Well, remember that I have this ellipse. It's been shifted to -1. So this is where we're going to start. And the ellipse goes 5 in the x, 3 in the y, right? My a is 5, my b is 3. So I'm going to go 5 in the x direction and then 3 in the y, which means 2, 3, 4, 5, 6, 7. I need to have distance of 5 on my axes so I can go that distance. And then I'll go 1, 2, 3, 4, 5, 1, 2, 3, 4, whatever. So I would need to go, like I said, 5 from the center, 5 in the x. So 1, 2, 3, 4, 5. I would be over here. So this is at 7. I would then go 5 the other way. 1, 2, 3, 4, 5 here. And then I would go 3 up. 1, 2, 3. And then I would go 3 down, 2, 3. And so I need to be passing kind of through these things. So your ellipse would look something like this, right? Obviously, if I'm touching that point here. So my vertices are going to be in the x direction, right? I'm going on that major kind of axis there. So in the x direction from the center, 5 in the x positive or 5 subtractive. So I will have in the x direction, I will take my center of 2 and I will plus or minus my a value, right? Which is 5 here, right? So plus or minus that. And then the y value would be -1. I'll stay at that height. Which is, either 7, -1, or -3, -1. So those would be the two. Yeah. So obviously we wouldn't use like the plus or minus form. That's just going to be showing this, but we'd have these two as the 0.7, -1 on the right, through -3, -1 on the left. I would also find things like the foci of this, right? And the foci are going to be somewhere inside, right? So we're going to have things here and here. Now the question is we have to find what the foci are. Remember, for an ellipse, to find that, it was a distance c. So with our ellipse, we knew that c squared was a squared minus b squared, which means that c is the square root of 25 and 9. That's a squared b squared, which is square root of 34, right? So square root of 34. What I will do then is take this, and that means that my foci are going to be square root of 34 away from my current location. And that tells me that it would be center 2, and then I go either that distance C this way or that distance C this way. So you're going to add or subtract root 34. Okay, the y value didn't change, right? I'm still on this like major axis here. I'm still on that line y equals -1. I'm just moving left and right. So here I would just stop here. Yeah, I mean, you could write the two equations if you want in this. There's not really a way to combine, obviously, 2 and the square root of 34. So I would just stop there, and that would be my final answer. Okay. So again, as we can see, right, what do? We recognized what shape it was. I found its center. Once I kind of drew a quick sketch, obviously this might come once you get these pieces, but I think making the sketch almost first helps you to find these pieces of information. So yeah, that's our process. Okay. We could do this again with any of these. I think the sentiment is pretty much the same, right? You need to recognize the form and then just shift the original point by whatever you have, right? So instead of it being at 0, if you found, A was 5, you would have just normally said -5 and 5. Now you need to think from the center point or wherever, right, we're basing out of, you will then shift that new amount. Okay, that's the important part. So I would definitely keep practicing these. I'm not going to go too crazy. A bunch of these, I think, for the most part, we kind of figured that out. But what I want to do is I want to talk about recognizing these forms. So this is, again, very hopefully clear that this is going to be an ellipse. It's given in the direct form of that, but we're not always given it in this kind of immediate form. Sometimes we're given it in a general form, and that's going to require us to basically do completing the square. And not only that, we're going to have to basically do a completing the square twice. Yeah, on the x and the y dimension. So what does that look like, right? So again, let's kind of talk about this. I'm referring to a general form. And this general form looks like, I could go crazy. Who knows? AX squared plus BY squared plus CX plus DY plus E equals 0, something like that, right? Where there's some x's squared and y squared, there's some x and y power 1, and then there's some constant as well. This is not like the most direct one. That there could be some formulas that show you what the quote unquote general form is. This is just kind of one that I put together, but the sentiment is there is everything written all together, right? There is no this term squared over that, whatever. It's not written very nicely in immediate form like we saw up above. So again, the idea is we take this guy down here, and what we're going to do is we are going to have to factor and really complete the square, right? Get into these factor terms to look like this. Okay, we're going to need to complete the square on both x and y terms to get this here. So let's do this with an example. Hopefully everyone remembers our completing the square process, but I'm going to go ahead and do one here. So let's say y squared minus 8x plus 4y plus 28 equals 0. I want to take this kind of general form and I want to put it in my standard form of whatever this conic section is, right? You're not told what it is, so we are going to have to identify what's going on here. So here's what I'm going to do. Yeah, I'm going to, like usual, put the y squared and the 4y's together. So you put everything with y's on that portion. Then what I'm going to notice is that I've got this x and there's only x. There's no x squared, which means this is probably going to be a parabola, right? There's some y squared term. There is no x squared term. So it's like an x equals an x squared situation. That's going to be our parabola case, right? So I would go over here. What I'm going to do is I'm just going to move the 8x on this side, and I could also move the 28. Okay? It doesn't really matter, right? The 28 I'm hoping is somehow gonna get handled, right? In some capacity. So I'm gonna maybe just move it over here for now, and let's see kind of what happens. When I complete the square, yeah, I would take this 4, I would divide by 2, and then I would square it. So 4 over 2 is 2, 2 squared is 4. So I would want to be adding 4 here. and I would want to be adding 4 here, right? Adding 4 and adding 4. So what that means is I now have on the left side y plus 2 squared, perfect square, and on so the left side, and on the right side, I have 8x minus 24, which is the same thing as if I pull out the 8, x minus 3. Okay, so this is sort of looking like y squared equals 4px, sort of looking like that, right? Only difference is y has been shifted by 2, x has been shifted by 2. Yeah. So what we notice here then is I have a parabola, and what do we have about this parabola? What do we know? Well, I know that 4p is 8, and so p is 2. And so given p is 2, what does that mean for us, right? So thinking back to our parabolas, well, with the parabola, we had this vertex, we had this directrix, and we had a focus, right? So we wanted to go from this and kind of get those pieces. So vertex, directrix, all that. So let's do this. Right? Sketch, as usual, might give us some better insight here. So what I've done is I've gone shifted my vertex from 0, 0 to now x3, y negative 2. So 1, 2, 3, 1, 2. So 3, negative 2. This would be where my vertex is, right? This is where the parabola is going to open from. It is x equals y squared, which means we are going horizontally, right? We're opening left, right? As of course x gets bigger, y also gets bigger, vice versa. So we are going to be kind of opening to the right, right? As x gets bigger, the y also gets bigger, opens up. So that makes sense. So we're going to open like that. I'm just going to draw a quick sketch of what that would be. Yeah. So we have this. And then what I will do is I will want to find the directrix, which should be p distance away. And then I will want to find my focus, which is also p distance away. What I found was that p was 2. And so I have my directrix over here at x equals 1. I should label this as obviously positive 3, right? X equals 1. And then I also know that my focus is over here at 5, right? So it is at x is 5, y is negative 2. If we want to label the points, we probably should, right? So the vertex is labeled as 3, negative 2. The directrix I have x equals negative 1, x equals positive 1 already, fine. And then 5, negative 2 for my focus. So not a huge difference either, right? With this, obviously, yeah, sure. I do have to do completing the square, but we've talked about completing the square, right? We are not necessarily experts at completing the square, but at least we can complete the square. We should be able to do that. Okay. So we'll also have some problems like this. Again, you will get some practice on completing the square. And then the only difference we're going to see is that when you do this, you are obviously getting this kind of nicely factored form. This will show you what we're shifting by. And note here, you might need to factor something out, for example, like we did on the right side, because this is not a completed square. Yeah, it is just a simple factor. You pull out the terms to get it into the shifted. So with all this being said, what we kind of noticed then is that there are some specific patterns. So even without completing the square, we should pretty much be able to identify what type of conic section we have. So I'm going to talk through how we kind of do that. So here, identifying conics from their general form. So from general, and I'll say general equation. So I want to identify my conic from its general equation. How might I be able to do this? So let's say I've got that ax squared plus bx blah, 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 right? So ax squared, and we can call it, whatever. I'll do capital A for the sake of it. Let's say A, maybe I use C, y squared. Again, there's not a set in stone form I have to worry about. I can really call these constants whatever I want. I'm just going to use these for the sake of this. If this is my general equation I have, right? So I have some arbitrary equation in this form. What I know is that I would say, okay, I have a parabola if only one variable is squared, right? So only one variable. So that's like either the x is squared or the y squared. You're missing essentially one of these terms. So in that example we did earlier, we only had one of those variables squared, so we knew it was parabola. Okay. So that'll be what we got for that. We can also do circle. So what happens with their circle? Well, the circle is both variables being squared with equal coefficients, right? With equal coefficients. So in this case, equal coefficients would be A and C. In our example, are the same, right? A and C with the squared terms, these are equal. In the other case, I guess we could go back to the parabola. This would be a case where either A is 0 or C is 0, right? So that would mean one of the two square terms doesn't exist, which means that has to be equal to 0, right? We have the ellipse. Yeah, ellipse is next. So ellipse, with the ellipse, we need both variables squared. We need them to have with the same sign. They're both positive, both negative, whatever, but they have to have different coefficients, right? So basically that means A is not going to be equal to C, and A, C signs agree. Okay, so a lot of this is having to do with the squared terms, right? We're looking at the coefficients, we're looking at um, how those compare, whether they're zeros or not, whether they're the same sign or not, all of this different type of stuff. Last but not least, our hyperbola. What would happen in the hyperbola case? Well, the hyperbola, we need both of our variables to be squared. We want them to have opposite signs, right? So this is A and C differ in sign. That would make sense, right? Because remember, with the hyperbola, we had like x squared minus y squared. So you want these to essentially have one positive and then one negative. Okay. So we'll do an example or two here. We'll give some equation in this general form. And our goal is to identify kind of what type of conic section we're working with, hopefully without having to do the completing square. Right? So looking at this right here, I have 3x squared plus 3y squared minus 12x plus 6y equals 0. And what I notice is that these square terms, I have one of each, right? So I have x squared and y squared. So that gets rid of parabola. These are the same sign, which means that gets rid of the hyperbola. And their coefficients are equal. So therefore, this would have to be a circle, right? So we've got positive 3x squared, positive 3y squared. They're both same sign, which means as long as the coefficients are the same, then we'd have a circle, right? That's what we wrote up here. So if the coefficient is the same, it would be a circle because when you factor it, they will both have the same number out front, which means that will kind of go away to the r squared value on the right side. And we could confirm that obviously with actually doing the completing the square. I'm not looking to do that, but we should be able to recognize, okay? So without even going through the whole process, we should be able to kind of see what we're working with. And then we should be able to go through the process and then actually get the final value, yeah? Let's look here. We have x squared and y squared, so both are squared. What we notice though is that they have opposite signs, right? So it is a minus right away. There's only one that has an opposite sign. That's a hyperbola. So we have a hyperbola. Right. Do one more. to wrap this up here. So with this, we've got, let's see, like 2y squared plus 8x plus minus 4y plus 1 equals 0. This one should be almost an immediate as well. This is going to be a parabola, right? It's going to be a parabola. And the reason we know that is because there is no x squared term, right? There is a y squared term. There is no x squared term. So the only conic that we had where one term was squared and the other was not is a parabola. Okay, so this is our conic sections. Obviously, I encourage everyone to continue to work through the homework. The more practice we do with the conic sections, the easier it becomes to recognize what we are working with. So that'll be what we're spending our time on here. Okay, if there are any questions, please reach out.